The moon has always been an object of fascination for mankind. It's a prominent view in our night sky, massive and close enough that its beautiful and eerie details are visible to the naked eye. Over 5 decades ago, humanity took its first steps on the lunar surface, yet even today, there's still so much we don't know about it. Exploring any place beyond Earth is incredibly dangerous and difficult, but the moon holds secrets that could change the course of human history. While it seems like a barren alien world, there's one discovery that has scientists buzzing with excitement. Water. Yes, water on the moon. But this isn't just any water. It's mysterious, elusive, and defies expectations. It doesn't always show up where we expect it, and by all accounts, it shouldn't even exist where we find it. This lunar water is the key that could unlock the solar system for humanity, and nations around the world are racing to uncover its secrets. Whoever cracks the mystery first will reap unimaginable benefits. But where is this water hiding? How do we know it's there? And how close are we to overcoming the moon's deadly challenges to claim it? For centuries, the moon was thought to be a dry, lifeless rock. But in 1976, a Soviet robotic probe, Lunar 24, landed on the moon, drilled 2 meters into its surface, and returned to Earth with soil samples. To everyone's shock, the samples contained water, about 0.1% of the material. Even more intriguing, the concentration of water increased with depth. However, scientists dismissed it as contamination from Earth, just like the trace amounts of water found in samples from earlier missions such as Apollo 11. The question of whether water truly existed on the moon remained unanswered. The mystery deepened in 1994 when NASA's Clementine mission revealed the existence of permanently shadowed regions near the moon's south pole, areas untouched by sunlight for billions of years. This discovery sparked a wave of excitement. Could these frigid craters, where temperatures never rise above -173 degrees Celsius, -280 degrees Fahrenheit, harbor frozen water ice? The possibility was tantalizing. In 1998, NASA launched the Lunar Prospector spacecraft to hunt for clues. While it didn't provide definitive answers, it detected large amounts of hydrogen at the poles, hinting at the presence of water ice, anywhere from 10 to 300 million tons of it. But hydrogen alone doesn't confirm water. It could also be hydroxyl OH, a close chemical relative. To settle the debate, NASA intentionally crashed the Lunar Prospector into the moon's south pole in 1999, hoping the impact would release water vapor detectable by Earth-based telescopes. Unfortunately, no water was found. The mystery persisted. In 2007, Japan's Selene Kaguya spacecraft took high-resolution images and mapped the lunar surface, but failed to detect water ice in the shadowed craters. Like its predecessors, it too was crashed into the moon in a final attempt to uncover water, but again, no evidence was found. Then, in 2008, India's Chandrayaan-1 mission changed everything. Unlike previous missions, Chandrayaan-1 carried an impactor designed to detect water vapor in the moon's thin atmosphere. As the impactor descended for 25 minutes before crashing near the South Pole, it sent back data confirming the presence of water. Months later, the Moon Mineralogy Mapper aboard Chandrayaan-1 also detected water from orbit. The discovery was monumental, but NASA wanted more proof. In 2009, NASA launched the Lunar Crater Observation and Sensing Satellite LCORRS mission, along with the Lunar Reconnaissance Orbiter LRO. Across had one goal: to confirm the presence of water ice in a permanently shadowed crater. In a bold move, the mission crashed the spent upper stage of its rocket into the moon, followed by the spacecraft itself flying through the resulting debris plume. The data was undeniable. Water ice existed in the shadowed craters, alongside other valuable materials like hydrogen gas, ammonia, and methane. The debate was finally settled. Today, scientists estimate that the moon holds a staggering 600 billion kilograms of water ice, equivalent to the weight of 461 million cars. But how did this water get there, and how has it survived? The moon's surface temperatures can reach a scorching 127 degrees Celsius in direct sunlight. Yet, in shadowed regions, they plummet to a bone-chilling negative 240 degrees Celsius. These extreme conditions, combined with the moon's low axial tilt, have allowed water to accumulate in permanently shadowed craters over billions of years. Comets carrying water likely impacted the moon, depositing water in these frigid traps where it remains frozen and untouched by sunlight. But the story doesn't end there. The LRO discovered something even more astonishing: trace amounts of water molecules scattered across the moon's surface, moving in a lunar water cycle. During the hottest part of the day, the water dissipates, only to return as temperatures drop in the evening. This revelation means that water isn't confined to the shadowed craters. It's everywhere, albeit in tiny amounts. But how does this water exist on the sunlit surface without evaporating into space? Scientists have proposed several theories. Micrometeorites raining down on the moon could carry small amounts of water, depositing it upon impact. Alternatively, the sun's solar wind might deliver hydrogen to the surface, where it reacts with oxygen-bearing minerals to form hydroxyl, which is then transformed into water by micrometeorite impacts. This water could be trapped in tiny glass beads formed by the heat of impacts, or hidden between grains of lunar soil, shielded from the sun's harsh rays. The implications of this discovery are staggering. Water is the oil of space, a precious resource that could revolutionize space exploration. It can be used for drinking, growing plants, and even producing rocket fuel. Hydrogen and oxygen, the components of water, are the primary materials used in rocket propellants. Launching fuel from Earth is incredibly expensive and resource-intensive, but producing it on the moon, with its lower gravity, could make space missions far more affordable and open up the solar system for exploration. The race to harness lunar water is already underway. China, in collaboration with Russia, plans to send 3 missions to the moon's south pole by 2029, aiming to establish a robotic station by 2030. Meanwhile, NASA's Artemis program aims to return humans to the moon by 2025, with a lunar base planned for the 2030s. The moon's real estate is becoming hot property, with nations and private companies vying for a piece of the action. But the moon holds more than just water. Hidden in its soil is a substance that could power the future: helium-3. Rare on Earth, helium-3 is a clean and efficient fuel for nuclear fusion reactors with no radioactive waste. The moon, bombarded by solar winds for billions of years, has absorbed vast amounts of helium-3 in its soil. While concentrations are low, the sheer volume makes it a tantalizing resource. China has already stated that mining helium-3 is a primary goal of its lunar exploration program, and other nations are following suit. The moon is no longer just a distant rock in the sky. It's a treasure trove of resources that could propel humanity into a new era of space exploration. But as nations and corporations set their sights on the moon, questions arise. Are we exploring for the betterment of humanity? Or is it the lure of profit driving this new space race? Whatever the answer, one thing is clear. The moon holds the keys to our future in space, and the race to unlock its secrets has only just begun. The moon's regolith, the layer of loose, fragmented material covering its surface, is a treasure trove waiting to be unlocked. If humanity ever mines for helium-3, a rare and valuable resource for clean nuclear fusion, it's almost certain that miners would also extract other minerals found in the regolith. But what exactly is hidden in this lunar soil? The answer is astonishing. The moon's regolith is packed with a variety of minerals, each holding the potential to revolutionize space exploration and sustain future lunar colonies. A false-color mosaic of the moon reveals a kaleidoscope of mineral deposits, with metals like iron, titanium, aluminum, silicon, calcium, and magnesium present in significant quantities. While some of these metals are locked in hard-to-access oxides, extracting them could yield valuable byproducts like oxygen and hydrogen, essential for breathable air, fuel, and even water production. Unprocessed regolith itself could be transformed into lunarcrete, a building material for lunar infrastructure, or melted down to produce glass. Remarkably, some plants can even grow in lunar regolith, offering a potential path towards self-sustaining food production for future colonies. But the most game-changing discovery lies in the presence of rare earth metals. Ironically, rare earth metals, despite their name, are not exceptionally rare on Earth. The challenge lies in their dispersal through the Earth's crust, making them difficult and environmentally damaging to mine. Only a few countries, most notably China, have tapped into significant deposits. China controls a staggering 95% of the global rare earth market, giving it immense geopolitical power. These metals are critical for modern technology, from electronics to electric vehicle batteries, and as demand skyrockets, the question arises, should we continue to ravage Earth's environment or look to the moon for these resources? While rare earths aren't more abundant on the moon, their extraction there would avoid the devastating environmental and human costs associated with terrestrial mining. As demand grows, lunar mining could become not only viable, but economically transformative, with control over these resources offering a strategic advantage in the global market. The race is on, and the stakes are astronomical. But who has the right to mine the moon? The answer is murky. The Outer Space Treaty, signed by most nations, prohibits claiming celestial bodies, but doesn't explicitly address mining. Other proposed treaties have yet to gain traction, leaving a legal grey area. For now, it may come down to a simple principle: first come, first served. This makes mapping the moon's surface and locating usable water ice even more critical. Water is the lifeblood of any lunar colony, but extracting it from the moon's poles is no simple task. Beyond the extreme cold, there's a hidden danger: electricity. The moon's low inclination causes solar winds to sweep across its polar regions, creating electric fields that can charge craters to hundreds of thousands of volts. This phenomenon, combined with the abrasive and toxic nature of lunar regolith, poses serious risks to explorers and equipment. Even spacesuits, like those used in the Apollo missions, are vulnerable. Made of woven Teflon, they attracted electrostatic regolith, creating a triboelectric effect that could shock astronauts. While sunlight can mitigate this effect, permanently shadowed regions remain perilous. To overcome these challenges, innovative solutions are in development. NASA has funded projects like liquid nitrogen dust capture systems and electrodynamic dust shields, which use charge panels to repel regolith. Meanwhile, companies are pioneering human-machine interfaces that could allow astronauts to control robots remotely, reducing their exposure to hazardous conditions. Despite these advancements, setbacks remind us of the difficulties ahead. In 2024, NASA cancelled its Viper rover mission, designed to explore the Moon's south pole for water ice, due to budget constraints and delays. This decision was a blow to lunar science, leaving a gap in our ability to study subsurface water deposits. Other missions have also faced challenges, with 5 of the last 9 moon landing attempts ending in failure. Even when successful, the mystery of lunar water deepens. Despite spectroscopic evidence of water, direct observations often come up empty, leaving scientists puzzled. Enter South Korea's Danuri probe, which arrived in lunar orbit in December 2022. Equipped with ShadowCam, a highly sensitive camera developed in collaboration with NASA, Danuri has provided unprecedented views of the Moon's permanently shadowed regions. Yet even with this advanced technology, no clear evidence of water ice has been found. Images of Shackleton Crater, for example, reveal a rugged landscape, but no obvious ice. This discrepancy between spectroscopic data and visual observations raises more questions than answers. India's Chandrayaan-3 mission further complicates the mystery. While its predecessor, Chandrayaan-1, first detected water on the Moon, Chandrayaan-3's findings have been unexpectedly inconclusive. Launched in July 2023, the mission successfully landed at the Moon's south pole, making India the 4th nation to achieve a lunar landing and the first to touch down at the pole. Despite its historic success, the mission failed to locate the water ice scientists expected to find. This deepening mystery underscores the challenges of lunar exploration and the need for continued innovation. The Moon holds the keys to humanity's future in space, but unlocking its secrets will require overcoming immense obstacles. From deadly electric fields to toxic dust and elusive water, every discovery brings new questions. Yet, the potential rewards, self-sustaining colonies, clean energy resources, and a foothold for deeper space exploration, are too great to ignore. The race to the Moon is no longer just about exploration. It's about survival, innovation, and the future of humanity. As nations and private companies vie for a piece of the lunar pie, one thing is clear: the Moon is no longer a distant dream. It's the next frontier. The Moon's surface is a treasure trove of secrets, and the Chandrayaan-3 mission was designed to uncover them. Equipped with cutting-edge tools, the Pragyan rover was ready to analyze the chemical composition of the lunar soil. Using an alpha particle X-ray spectrometer, APXS, it fired radiation at the surface, studying the wavelengths that bounced back to identify elements. Complementing this was the laser-induced breakdown spectroscopy, LABS, instrument, which fired lasers at targets, creating plasma, and analyzing the light emitted to reveal the composition of the Moon's regolith. Together, these instruments were poised to confirm the presence of water and other intriguing substances, providing scientists with groundbreaking insights. And so, Pragyan got to work, deploying its instruments and scanning the lunar surface. Within days, the results began pouring in. The rover detected a variety of elements, including aluminum, calcium, iron, chromium, and titanium, alongside oxygen, a crucial find for future lunar colonies. But the most exciting discovery was the first ever in situ measurement of sulfur at the Moon's south pole. Sulfur is a game changer. Its presence hints at past volcanic activity and offers clues about the Moon's geological evolution. Yet, despite these remarkable findings, one critical element was conspicuously absent: hydrogen. Without hydrogen, the dream of finding water ice, a resource vital for sustaining life and fueling space exploration, remained unfulfilled. Pragyan's mission was far from over. Guided by scientists on Earth, Pragyan embarked on a cautious journey across the lunar terrain. Navigating the rover was no easy task. With a signal delay of nearly 3 seconds between Earth and the Moon, every command had to be carefully calculated to avoid disaster. At one point, Pragyan narrowly escaped tumbling into a massive 4-meter crater that scientists hadn't initially detected. Moving at a glacial pace of just 1 centimeter per second, the rover covered a mere 100 meters over its 2-week lifespan. Despite its slow progress, Pragyan's journey was fraught with challenges. When it encountered a second crater, it chose to navigate around it rather than venture inside. No photos of this crater have been released, leaving us to speculate whether it held any hidden ice. Meanwhile, the Vikram lander was busy conducting its own experiments. It measured the Moon's surface temperature, digging 10 centimeters deep, to record temperature variations at different depths. Vikram also analyzed the plasma content of the thin lunar atmosphere, confirming that radio communications would face minimal interference, a crucial finding for future missions. In a stroke of luck, the lander even detected a possible moonquake, a rare event captured within its short operational window. As its mission neared its end, Vikram performed a daring 40-centimeter hop, firing its boosters to lift off the surface and land 30 to 40 centimeters away. This maneuver was a test of future technologies that could one day enable landers to return to orbit from the Moon. Yet despite these achievements, the mission's primary goal, finding water ice, remained elusive. By September 4th, time had run out. Vikram and Pragyan were powered down as the lunar night approached. Scientists hoped to revive them after the 2-week-long night, but the extreme cold proved too much. The two explorers had transmitted their final data, leaving behind a legacy of groundbreaking discoveries. The mission was hailed as a success, providing invaluable insights into the Moon's composition and history. But it also deepened a mystery that has puzzled scientists for decades. Where is the water ice that previous missions, like Chandrayaan-1, detected from orbit? When water ice was first discovered on the Moon, many imagined vast frozen lakes or shimmering frost-covered craters. Yet, despite spectroscopic evidence, no mission has directly observed this ice on the surface. Pragyan's analysis of the regolith revealed no trace of water molecules, raising questions about where the ice is hiding. The answer may lie beneath the surface. Vikram's temperature readings offered a tantalizing clue. Using its Chasta sensor, the lander measured temperatures at different depths, starting at the surface and probing 10 centimeters down. At the surface, temperatures soared to nearly 60 degrees Celsius, but just 8 centimeters below, they plummeted to minus 10 degrees Celsius. This dramatic drop revealed that lunar regolith is a poor conductor of heat, suggesting that any water ice is likely buried beneath the surface, shielded from the sun's scorching rays. The Chandrayaan-3 mission may not have found water ice, but it provided a crucial piece of the puzzle. If future explorers hope to quench their thirst on the moon, they'll need to dig deep. The moon's water cycle remains a mystery, with questions about how water moves across the surface and whether it's affected by solar radiation. Chandrayaan-3's brief but impactful mission has given us a clearer picture of the challenges and opportunities that await us on the lunar frontier. As we continue to explore, one thing is certain: the moon holds secrets that could transform humanity's future in space. And if we're going to unlock them, we'll need more than just rovers and landers. We'll need shovels. Over the years, space exploration has gifted us with breathtaking images that capture the grandeur of the cosmos. These visuals are more than just snapshots. They're windows into the vast, awe-inspiring universe that surrounds us. To celebrate these moments, a collection of premium 70 by 50 centimeter posters has been created, featuring stunning artwork inspired by the most iconic scenes from space exploration. These prints are perfect for adding a touch of cosmic wonder to your home or office, serving as a daily reminder of the beauty and mystery of the universe. For a limited time, these posters are available at a special early bird price. Visit the link in the description to explore the collection and bring a piece of the cosmos into your life. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. If you haven't already, consider joining our community to enjoy exclusive benefits, including ad-free videos, your name in the credits, and the chance to submit questions to our team. Together, we can keep exploring the stars and uncovering the secrets of the cosmos. Don't forget to check out our playlist for more incredible space content. Until next time, keep looking up